Hi children, welcome to your home school. This is your next session of your mathematics basics. In this session, we are going to learn about highest common factor or greatest common divisor. What is this short form, children? HCF or G.C.D. So, in our mathematics, mostly we hear the word HCF. Find the HCF of two numbers, find the HCF of three numbers. How to find this highest common multiple? So let's have a look here. What is this definition? HCF is the greatest number which divides two or more numbers completely without leaving any remainder. So here, what is HCF, children? We know about the factors, right? All the factors of the number and which is the highest factor. Highest in the sense, the greatest number in that two numbers compare, and that is called as the HCF of the number. So how to find? So there are two methods here, children, to find HCF or G.C.D. Both are same. So how to find here? One is prime factorization method. Prime factorization method, and another is successive division. What is successive division? We know about a division. But what is this successive? Let us see both the methods in this session now. So look here. Let's see the example here. What is this example here? Find the HCF of 36 and 84. Look here, children. So what do you know? First method we go here. That is prime factorization. When we are doing prime factorization, only prime factors we need to write here. So let's do here. 36 is equal to 84 is equal to, right? Let me do the division part here. 36 do division by only prime factors, right? So now 6, this means it is an even number. It can be divisible by the smallest even number, that is 2. 2 ones are 2. In 3, if you remove 2, 1 will be left, 1 will be carried here, that is 16. 2 8s are 16. Now, 2 table, do you get 18? Yes, 2 9s are 18. The next table here, children, you should not take 9 ones. 9 is not a prime number. So now what I need to take here? 3 3s are 9, and again 3 1s are 3. So one division is completed. Let us write what you have. 1, no need of writing. You can skip while you are writing factors. 2 into 2 into 3 into 3. Okay. So now next step. What's your next number here? 84. 84 always do with the prime factors, children. Now 2 4s are 8, 2 2s are 4. Then 2 2s are 4, 2 1s are 2. So 2 table you can't get 21. So which table we are going to consider here? 3 table. So let's take 3 7s are 21 and 7 1s are. So look here. You should not take directly 4. 4 is not a prime number. You have to split your numbers by 2 times 2. Means one time you multiply 2 and again you multiply with 2. But don't multiply with 4. And here 3, 7 you got. So now right here, how do you write this? 2 into 2 into 3 into 7. So now we did not complete our HCF. We have just done our prime factors. Right? We have written here prime factors. So now how to find HCF? Listen here carefully, children. I'm going to show you one method. Very easy. Which is very easy. What is the highest common factor means? Normally observe and you say 3. No, not like that. So how to understand this? In these two sets, okay, so which numbers are common? First identify that. In both the sets, a number should be common. So here 2 is there in this and also in this. So what do I do here? Is common, just round up that number here. Now Again, 1 more 2 is common in 2 sets. Right, children? Now, 3 is common in this 2. Right? So now, which is common? Write one time. I will write here 2, 2, and what is this number? 3. So, which is repeated in both the numbers, that number write one time. Now, HCF of 36 and 84 is equal to, what is HCF here? What you have written down the numbers, those you multiply, children. 2 into 2 into 3, that will be 2 2s are 4, 4 3s are 12. 12 is the highest common factor or a greatest common divisor. So look here, children, have to find HCF of two numbers. Do the prime factorization first and then write one below the other. Then check it out which number is common in both the numbers. Round up, write one time. Only those numbers you multiply and say it as a HCF. Same I am going to say you in LCM, children. Same I am going to use. But what is the difference here, HCF and LCM? Along with this remaining numbers, if you multiply, you are going to get your LCM. Least common multiple. We are going to learn about LCM in our next session. Now, second problem, look here, children. 15, 25, 75. See here, I have given you three numbers. Find the HCF between these three numbers. What is the highest common factor? How to find, children? You have to do division and find what are all the prime factors there. So now, 15, 25, 75 equal to, right? So now we are going to do here prime factors by division method here. So 15 in which table, children? Let's go with the 3 table. 3 5s are 15 and again 5 1s are 5. How do you write this? See here, I have said you no need of 1. 1 if you want, you can write 1. If you multiply any number with 1, you will get the same answer. So now, how do you write this one? 15 factors. 3 into 5. We get 15. Now, next number is 25. So, 5s are 25. So, how do you write, children, here? 5 into 5. So, these prime factors division you can do in rough column, not in your book. So, next 75. So, look here, 75. Which table, children? Let's go with 5 table. 5 1s are 5. So, 2 will be left in 7. If you remove 5, 2 will be left. So, 25. What it will be? 5 5s are 25. Then again with the 5 table, 5 3s are 15. 3 1s are 3. See here, whatever I take the number is a prime number. So, prime factors only I have taken. Now, write this. How do you write here? 3 into 5 into 5. Right? Now, what is the HCF of these three numbers? So, here, look here, children. What is the HCF? You can write it here. HCF. You can write H of 15, 25, 75 is equal to. What is this equal to? So, where is the answer here? In all the three, that number should be there. Check any number is common in all the three numbers, round it up and write one time. That is a method of finding HCF. See here, 3 is there in only 2 numbers. So, I cannot take in HCF. So, what is common? 5 here, there and here and here. So, in all the 3 factors, 5 is there. So, what do? Just round 5 and write one time. Is there any other number which is common in all the three numbers? No. So what you are going to say, HCF of these three numbers is equal to 5. This is your answer. Okay. So what is the main technique here, children? First, write all the prime factors of a given number. Then check in all the 3 or 4 or 5 any number. So is there any number common in all the numbers? You have to check out. See here, it should be common in all the numbers. Then only you can say that it is the highest common factor. If it is not there in any one number, we cannot consider it as a highest common factor. Suppose you may feel, what is let's take a 3 and 5. What is HCF of 3 and 5, children? Nothing is common. Nothing is common in the sense we cannot say that there is no HCF. It is there. How to write 3 and 5, children? I will write it as 3 ones and I will write it 5 as 5 ones. So in these two, what is common now? 1 is the HCF. See here, when nothing is common in between two numbers, you have to write HCF of that two numbers is 1. Okay, don't forget this point, children. Now let's move to the next problem. What is the next problem? 120, 136. See, to do anything, we should do some rough work. See here, this part what we have done is a rough work. Okay, this rough work, you draw a right side one column in your notes and always try to do rough part towards right of your paper. So now 120, 136. So shall I do the prime factorization here? 120. With which table we are going to do, children, here? With the 2 table. 2 6 12 0. Again 2 3 6 0. Again, if you want to, you can take 2 1s are 2. Look here, 1 is left, 1 0, it becomes 10. It will be 5 2 5s are 10. Then 3 5s are 15. 5 1s are. Okay, so now how do you write this 120, children? We are going to write it as, look here, how many 2s are there? 2 into 2 into 2 into 3 into 5. So into 1. If you want, you can take 1. Otherwise, you can skip 1. Next, 136 is equal to. So now let's do here 136. So 2 table, 2 6 12, 1 will be left, it becomes 16, 2 8s are 16. Then now 2 3s are 6, 2 4s are 8, 2 1s are 2, 2 7s are 14. So look here, children, 17 is a prime number, we cannot divide further. So what you are going to do here? 17, I cannot divide in any table. So 17 ones are 17. How do you write this? 2, 2, 2 into 17. So here, look, observe here, children. What are the common numbers? Round up and write one time. So 2 is common. If you want 1, you can write. 1 you can write and write 1, no problem. 2, another 2, another 2 is common. That's it. So look here, children. What is the HCF of 120, 136 is equal to 2 into 2 into 2. That is, see here what you have written down. These all numbers you need to multiply at last. 2 2s are 4, 4 2s are 8. 8 is the HCF of 120 and 136. See here, children, next we are going to do these two problems by using successive division. What is the successive division? How to do this? Look here. So which is the greatest number here? 25, right? 25, I am going to take it as a dividend. Okay. Then now I am going to divide this number using the other number. I take it as a divisor. Okay, 15, we won't get anywhere in our 15 table. So what is the number which is nearer? 15 ones are 15. So write that one here and then 15. So look here. So now subtract this one. 5 minus 5, 0. 2 minus 1 will be 1. See your children, successive division. This is the point you should understand. So here this division starts like this. Okay, so here what is this? This remainder, now it becomes as a divisor. Then what about your dividend? Before divisor it becomes the dividend. Okay, like this chain children, it will be interesting. Now divide children. 10 ones are 10. So again subtract, you are going to get 5. Then again, so now this remainder will become divisor. Before remainder will become the dividend. Now 5 twos are 10. So now you get it here 0. If you want, you can extend like this. So here children, see here carefully. This is the way we do the successive division in order to find highest common factor. This is useful for 3-digit number, or it may be 4-digit numbers. So here, where is HCF? When you are doing successive division, the last remainder, understand the word? The last remainder before getting 0. Before getting 0, what is the last remainder? Yes, 5. This is your HCF. HCF of 1525 is equal to 5. This is your answer. Okay, you may go with the prime factorization method or this division method also you can go. So let's see one more problem with this successive division here children. But first you have to find which is the greatest number that you are going to take it as a dividend, and the smallest number you are going to take it as divisor. So now 136 you have to divide by you can take up or side anyway you wish children. So 120. So it is nearer now 136. So I'll take it as 121 120. Subtract this children here. What you are going to get? 6 minus 0 will be 6. 3 minus 2 will be 1. And 1 minus 1 will be 0. So now this remainder will become the divisor. Before what we have taken divisor will become the dividend now. So now 16 table, we have to guess this number children. Okay, 16 table, where you are going to get nearest number? Let's take here 16 fives are how much here? 80. 16 6 are how much here? 16 6, or you may take it as 16 8s are 128 you got. Oh, it's more than 120. So what you are going to take here? You are going to find 16 sevens are 112. So look here children, you should remember 16 table. If not remember like this, guess numbers and do division. So now what you are going to write here children? 16 sevens are 112. Now again subtract here, take borrow. If you take borrow it will be 10. 10 minus 2 will be 8. Now again this remainder becomes the divisor. Before remainder will be dividend. Now 8 2s are 16. If you subtract, you are going to get the 0. See here children, what is the successor division? What you are going to get? Where you are going to get HCF here? The remainder before getting 0. So you have to end your problem with 0. The remainder before getting 0. See here, this is one remainder, getting 0. Before getting 0, what is the remainder? This is the HCF. So HCF of 120, 136 is equal to 8. This is your answer. These HCFs are very important in order to solve your algebraic expressions. Right? Let's try to learn this, and then if we are perfect, we can do any type of problems. So here children, we are going to end this session today. In our next session, we are going to start with LCM. While saying LCM, I am going to take some variables. Okay, we did not take any variables. We have taken only numbers in this part now. In our next session, we are going to take variables. With that, we are going to take HCF and also LCM. Thank you, children.